Okay, good morning. We are back. Hope you guys are doing well. Hope all your family is safe and healthy. Really, that's all that matters right now, right? So chapter 10, 11, I'm going to put it together into one chapter because they're very, very similar. So let's get started. It's a very long lecture. This is a really fun lecture to teach in the classroom. So we'll see how it goes. I'll probably go through it really quickly and try to keep it short and sweet because I've noticed people are not watching my YouTube videos or they're really not listening to the lecture. And I understand it's tough. So it is what it is. But some of you guys are. So I've been getting different types of feedback. We're going to be looking at organisms and the way that they are found across the landscape. So, geography is a very broad discipline, right? So we're going to kind of apply this geographic approach to the study of organisms, plants, and animals, okay? So organisms can differ in many ways. And there's this subfield of geography, which is called biogeography, one of my favorite topics and disciplines under geography. Good morning. My little doggy just woke up. Hi. He's like an old man. Choo-choo. What's she doing, Choo-choo? You guys just heard my dog mom voice. You want to go outside? Huh? Biogeography is a field of geography looking at how species and ecosystems are scattered throughout the landscape. So if you remember in the very beginning of the semester, I said that geography, we take like different types of information, right? And we make them more understandable, or we find patterns and similarities, right? And you kind of break that down. So we looked at the different spheres, the hydrosphere. Now we're going to be looking at specifically the biosphere, all living things. So the term biodiversity, which means biological diversity, it refers to the number of different organisms present in a location. So a place can have very high biodiversity, a lot of different types of organisms are present in that area, or low biodiversity, right? And so you don't have a variety of organisms, not really a lot, but just not a variety. So if we were in the classroom, I would ask, okay, class, where do you think you would find high biodiversity? You guys would be like, oh, probably the rainforest. You're like, yeah, you guys are really right. Yeah, the rainforest, a coral reef, those places, those have high biodiversity, right? In places like urban landscapes, cities, deserts, the tundra, these would all have low biodiversity. So when we look at biodiversity, there's a term called biodiversity hotspots, which describes different places on Earth that have obviously high biodiversity, but at the same time they are threatened with destruction. So it could be because of climate change. It could be because of land use. Most of the times it is because of land use. So many different reasons that are threatening that location and its existence has high biodiversity makes it a biodiversity hotspot. A biodiversity hotspot is a region with significant levels of biodiversity that's threatened with destruction. So this would be by the hand of man specifically, right? So this concept was first introduced by Norman Myers. The hotspots represent an opportunity for us as scientists or educators really to highlight this area and hopefully save this place before it is completely eradicated, right? So currently there's 34 of those on Earth. So you have to remember, yes, they're beautiful, but at the same time it's being threatened with destruction. So that's why they're getting this kind of like more infamy, right? So I'm going to choose two of them out of all the 34. This has different places on Earth. Obviously, we think of rainforests. Yeah, the rainforests are probably going to be really threatened, right? But there's other places. I mean, look at California. Is it surprising that we are a biodiversity hotspot way over here? California, Los Angeles is a biodiversity hotspot. Crazy, right? It's not something you would imagine to be a biodiversity hotspot. So I'm going to be highlighting the California Floristic Province and this area here, okay, the Lazar ecosystem. But, I mean, these are all hotspots all over the earth. The California Floristic Province, it does include the chaparral environment, which I talked about in Chapter 8, but it goes a little higher and it extends a little more than just our Mediterranean climate zone. The Mediterranean climate zone, yes, it is included. It's probably all this area here within this California Floristic Province, home to about 30,488 native plant species. Okay, so here in California, you have all these different things working together. You have a lot of geological activity, earthquakes, faults, which give us our rich soils, right? Which bring in the diverse plant life, which then bring in the insects and then bring in all these different types of endemic species. You have that coastal area. You have mountainous mountain ranges. You have the Central Valley, which has this fertile soil. So, I mean, there's a lot of things going on, and you have all these different climate systems. Up north, it's going to be a little bit more rainy. Down south, it's going to be drier, but you do have, you know, mild winters. So it gives us all this diversity, right? The California Floristic Province is a biodiversity hotspot, one of the only biodiversity hotspots in the developed world. That's crazy, right? And yeah, of course it's threatened. Why is it threatened? Well, that's easy, because of land use, agriculture being the main reason, right? We got to feed all these people, but the main driver is going to be human population. So here's just some of the animals that you would find that probably are currently threatened. This is the the San Joaquin kit fox. So cute, right? Our California mountain lion, then grown up over here, and our gray wolves. So I think a few weeks ago we did watch that gray wolf video, and how the reintroduction of a top predator will bring the ecosystem back to life, right? So California Floristic Province here, where we live, is a biodiversity hotspot. Biodiversity hotspot is going to be something more of what you would imagine, which is the Lazar ecosystem found in Sumatra, Indonesia. So if you look over here, this is where it's located. Parts of Sumatra, Borneo, this is all Indonesia, a different collection of islands right underneath Thailand, Cambodia, right? So this collection of islands sits right at the equator. Huge rainforest. This is the last place on earth where you find orangutans, rhinos, tigers, elephants still living together in the wild, right? So that's huge, but unfortunately it is threatened. And I know you guys watched the Racing Extinction video, and they did talk about it a little bit. So these orangutans are critically endangered. First of all, I mean, look how cute they are, right? Some people don't think they're cute. I think they're adorable. One of my favorite animals. They are closest to us in DNA. They're very, very smart. They also live with their mom, I think up to 13 years. I want to say it's 9 or 13 years, which is the longest out of any animal in the animal kingdom. Sorry, I had to pause it there. Yeah, so they stay with their mom the longest out of the whole animal kingdom. And so what that means is that when they leave, they come back and they visit mom. So they're really like this really tight-knit family, and they spend most of their lives in the trees. So what I'm getting at is, in Indonesia, there is a huge threat to the environment because of palm oil. So palm oil is a very cheap commodity. It's used in snack foods. It's used in detergent. It's used in almost anything as a stabilizer, or just this really cheap ingredient just like a vegetable oil, right? So instead of using vegetable oil, we are now switching to palm oil because number one, it's cheap, and it's not produced. Most of it is not produced here. So in this area, it's a very cheap commodity. So what they're doing is they're taking out the rainforest, clearing it, and when they clear it, they don't like chop down the trees. They burn the area and then they plant these palm trees, plantation style. So they're just rows, infinite rows of palm trees that give out this little, like this little orange ball. I should really learn the name to this, but it comes off the tree. You expel oil from it and it turns into palm oil. So that palm oil is used for the snack food company. I mean, makeup, you name it, it's probably in there. But who is threatened or who is at risk are these beautiful, beautiful animals. And a lot of times, 90% of the time, these loggers come out and they take down the rainforest and you find dead orangutans, the moms, and the babies clinging to them. So there are, these conservation groups and sanctuaries and nonprofit organizations out here trying to protect and save these orangutans, but that is not the life, right? They need to be in the wild and the free. So they are critically endangered because of our snack food industry. And so I'll have a few links on your module, and you'll have a few exercises. But there are some places that are banning this type of palm oil, and you as a consumer, you do have the power, you do have the right to demand conflict-free palm oil. So I don't know, guys. Really, really sad. So we'll see what happens with that fight. So here is just another map, a little bit closer of where it's located. This is natural forest cover in Sumatra, the island of Sumatra, 1985 versus 2009. If you see, this is, older data, right? If you see the red, that's where it's been lost. I mean, all that has been converted into these palm oil plantations. Okay, so let's talk about food chains. Food chains are an unending flow of energy, water, nutrients through the biosphere through direct passage from one organism to another, right? So you have organism A converting energy from the sun through photosynthesis into a type of energy or food. Organism B is a primary consumer, eats that plant, right? Then organism C, and so on. So throughout this chain, a lot of different things are being passed through the ecosystem, right? From living things to the ecosystem. And so this is how like nutrients, energy, water is moved from organism to organism within the ecosystem. So this would be a chaparral food web. It's easier to describe a food chain as a food web because it's not like organism A is eaten by organism B, C, all the way back to where it's decomposed, right? It's not just like this very black and white process. When you get into the secondary or tertiary consumers, things get a little bit more mixed up. There are some consumers that eat a variety of things. There are some consumers that will only eat what's beneath them, right? Does that make sense? So it's more of a food web rather than a food chain. This is a chaparral food web, but remember, chaparral is found in 5 different places on Earth in that Mediterranean climate zone. So this is not a Los Angeles or Southern California chaparral. This is actually a Australian chaparral. So you see that it is very similar. This fairy duster here would be something considerably close to our sage. We do have manzanita trees. It's a type of like oak-like tree. So very similar, right? But then over here you start to notice things are a little bit different. We don't have catamounts. We do have California mountain lions, very similar. We don't have dingoes. It would probably be like a coyote or a smaller predator. But very similar in type of vegetation, right? Okay, so this is web. Chain is a misleading term, it's more of a web. So your producers are going to be at the very beginning. These are autotrophs or self-feeders. They make their own food. Those are only going to be plants, right? Also algae when we're talking about these aquatic ecosystems, but producers are self-feeders. Consumers are primary consumers are going to be called heterotrophs or herbivores. They only would eat plants, right? And then again, this can go all the way to the quintary, I don't even know how to say it, the fifth consumer, right? Secondary, tertiary consumers. These are predators. There are many levels of these secondary consumers. Trophic cascade. So when we're looking at this food web or food pyramid, when you introduce or remove a top predator, there's going to be a lot of different types of changes within the ecosystem. And I'm pretty sure I had you guys watch this video already, so you know, right? If you introduce a top predator, your first thought would probably be like, whoa, everything's going to be ate or eaten. It's going to totally change the ecosystem. Yeah, but in a positive light. So if you remember that video, I think it was chapter 8. Yeah, I assigned it to you guys in your modules. It has a dramatic change in the ecosystem structure, even up to the physical geography, right? We saw at Yellowstone, the introduction of those wolves changed the meandering of those rivers. That's huge, right? So an addition or removal of top predator is going to have changes in the entire ecosystem when you do that. Here's just another scenario. You have before and after. So before you have the removal of a top predator. So this would be kind of like the opposite. So before you remove a top predator, look at how diverse this forest ecosystem is. After, if you remove a top predator like a wolf or a bear, more so a wolf, right, would be the top predator in this ecosystem, because bears are more like not just carnivores, so they do feed on plants as well. If you were to remove that wolf, there's a significant drop in biodiversity. Pollutants in the food chain, just like nutrients, water, all these things and energy flow throughout the food chain. Unfortunately, there are pollutants in the food chain that are moving through through aquatic food chains today. So we know the ocean is full of microplastics, tiny, tiny pieces of broken down plastic. They are so pervasive in the ocean. They have been found in zooplankton. So if you look at this picture here, that is how tiny these plastics are. Crazy, right? So the higher up the food chain, the more concentrated the pesticides become. So what I'm going to do Um, Here's just another explanation of that. At the very bottom, you have contaminants that are washed into the water. They build up in the sediment, right? Number two, your bottom dwelling organisms like mussels concentrate contaminants and are eaten by goby fish. Number three, predators like smallmouth bass continue to concentrate toxins by eating the goby fish, and then the bass are consumed by humans, right? So, I mean, think about of everything we try to do nowadays. Eat organic, be healthy, look at your ingredients, right? Try not to eat farm-raised fish. I know that's on some people's agenda. Eat wild-caught fish, but I mean, there are so many instances of this. I don't know if you guys heard last year that there was a large amount of cocaine found in shrimp. That is wild, right? Well, maybe not large amounts, but enough to be detected. So small amounts of cocaine, pesticides, and other contaminants have been detected in UK freshwater shrimp. So I think this was last year in May. Yeah, May of last year. Um, but for instance, like those contaminants in shrimp, the potential for any effect is very low, but it just highlights the ramifications of pollution, pesticide use, the over, production of really food, right? Pharmaceuticals too. Anything that goes down the drain is going to end up in our food. Okay, let's look at terrestrial flora. We talked a little bit about animals. We are going to continue to talk about animals the rest of the chapter, but let's look at terrestrial flora. So remember, flora and fauna is just a fancy way of saying plants and animals. Plants are just as competitive as animals. We tend not to think of them as competitive, but they are competing for things like space, light, soil, nutrients, water, especially in environments that don't have those resources, that those resources are limited, right? We like to think of animals being very competitive. They are. And I mean, it makes for a great nature documentary, right? The hunt and everything. But just as animals are competitive, plants are just as competitive. Of the dozens of plants that can grow in an area, only a few are likely to survive. So they're always competing for space to grow, for light, for nutrients, for soil, for water. So they're just as competitive as animals. When we look at plants, there is a term that's really important for you guys to kind of understand is the difference between native and invasive species. So native species is a plant that occurs naturally or has existed for many years. When we talked about the chaparral environment, I said that sage was native, coast live oak was native, right? All these native plants start to bring in that natural or those native insects that bring in that native wildlife, right? It just starts like this kind of chain. Here are some examples of native species within our area. So you have coast live oak found in the Santa Monica Mountains, I'm sorry. Here you go, really nice, right? You have sagebrush, really easy to find. You can smell it on your hikes. Manzanita trees, small, short trees. These are all drought-resistant shrubs. These are Jeffrey pines, one of the only pines native to California. And this is loco weed. Loco weed. Makes you crazy. I'm just kidding. It's just called loco weed. So the importance of loco weed, for example, this is a very small example. This is a Palos Verdes blue butterfly. They thought it went extinct, and when it's a tiny animal like this or a tiny insect, it seems not to get the attention that like a rhino would get, right? Or like tigers would get, right? They get all that attention because they're these huge, beautiful animals. And if you saw that movie Racing Extinction, they explained that very well. Like a tiny brown bird, nobody seems to care if a tiny brown bird or a tiny butterfly goes extinct. So they thought that scientists thought that it was extinct, but in 1995 they went out, because they're only found in the Palos Verdes Peninsula. They went out and actually found one, and it is very localized because it can only live where there is deerweed or loco weed. So, and it's very, very endemic to the peninsula of Palos Verdes. So that's just an example of how our native plants foster the biodiversity of an area. Okay, so we talked about native species, and what I want you guys to understand is that an invasive species is not only just from somewhere else or not native, but it has a negative impact on the environment. Okay, so you can very well have a plant that is not from the chaparral, and it grows well, but it's not invasive. An invasive species will have a negative impact, meaning it will overcrowd, or it grows too quickly and takes out that natural vegetation, or for instance, like an invasive species or exotic species of bird is just going to eat everything, right? It has a negative impact. So you can have a natural plant, a non-native plant, and it grows well and it doesn't have a negative impact, that's fine. But an invasive species has a negative impact. For instance, ice plant, that's this picture here. Mexican fan palms, these are not native and they're invasive. Yellow star thistle, Arundinodonax, I'm sure you guys have seen all these. Maybe you don't even notice plants, but I mean, these are really common in Southern California. Deforestation, when we're looking at forests, deforestation is just where natural forests are cleared through logging or burning to use the timber or to replace that area for our alternative uses. The main driver of deforestation is going to be agriculture. The main reason we are burning and clearing all our forests is not for timber, it is for land use. So either to raise cattle, or to grow feed for cattle, or to raise livestock or food for us. That is the main reason we are clearing our rainforest. In the Amazon, cattle ranching is a main reason. In the late 90s, it was soybean plantations. I can't talk today. Soybean plantations. In Indonesia, it's palm oil plantations. So, you know, it's not because we're chopping down trees to make paper out of them, right? That was like when we were little, that's what we thought, save the trees. It is really for our food, for food. That's the main reason. So here's just a picture of deforestation and how pervasive it is and how it separates ecosystems, right? If there is, I mean, any type of wildlife left over here, how will they get over here, right? If that is their reality. So these are just pictures I thought were kind of sad and interesting, right? Need money for my family in the rainforest, this picture here. Okay, so let's look at terrestrial fauna, moving on from plants to animals. Terrestrial fauna occur in much greater variety. There is many more animals than there is plants on Earth. Wildlife is an important part of physical geography because as geographers, yes, we're looking at the landscape, but we're not ignoring what is found on the landscape, right? Animals are more sensitive indicators than plants of the health of an ecosystem. Why? Because animals can just leave. If an ecosystem is not providing the resources an animal needs, well, they'll just go look for a new ecosystem. Unlike plants, right? Plants have to stay. Obviously, they can't get up and walk around, right? Plants will have to stay and try to hack it out or, you know, just survive through the drought or whatever it is that ecosystem is going. Characteristics of animals, they're very diverse. You have two universal characteristics. They're capable of self-generated movement and they're not able to make food. Different types of animals, you have invertebrates. These are animals without backbones. worms, sponges, mollusks, marine animals, creatures of microscopic size, and the largest category of invertebrates are arthropods. These are spiders or insects, right? So the reason I put a black widow picture there is because I was bit by a black widow twice in one day on my thigh when I was 16 years old. It crawled in my pants when I was using the restroom, and as I pulled up my pants, I felt fire on my legs, and then I grabbed something and I kind of like smushed it between my fingers through my jeans, and I looked and it was a black widow that I remember trying to kill earlier when I was cleaning the restroom. And I stayed the night at a hospital. They didn't have the anti-venom, so I had to go through these like body aches. They said it was going to be worse than labor. I remember everything hurt. And then they gave me morphine. And I will never forget what that felt like when the morphine went through the IV system. Yeah, it was pretty traumatic, but hey, I'm alive and I'm not afraid of spiders anymore. So there's your little story for the day. Vertebrates, these are animals with backbones. Okay, so you have fish, and there's 5 types: fish, amphibians, reptiles, and mammals. But so what mammals do is that they give birth to live young. That is one of their characteristics. Another one is that mammals have true hair, not just whiskers. So there's a couple animals in the world, or mammals, sorry, in the world that do lay eggs, but they are still mammals. These are called monotremes, egg-laying mammals. Only about 2 of them exist, an echidna and a platypus. And there is a small group of mammals that are marsupials. So marsupials have 2 different phases when they're giving birth. So like for instance, a kangaroo is a marsupial. The kangaroo will have like a baby inside her pouch, and she'll be pregnant. So she has 2 different types of milk. She lactates 2 different types of milk. One for her baby inside her pouch, and then if she has a baby outside of her pouch. It's really weird. She's like pregnant 9 years of her life. It's really interesting the way that happens. And the reason I have this jacked kangaroo here is because they do fight. They fight each other and they box each other for a fertile female. Isn't that cute? It's kind of like what you see at the bars, right, in downtown Fullerton. Just kidding. All right, so habitat destruction and wildlife impact. What are we doing to wildlife, right? What are our impacts on wildlife? Obviously, habitats are an essential resource, but unfortunately, habitats are becoming smaller and smaller. I mean, I just showed you the picture of deforestation. That's just one example, right? We see that in these rainforests, but even somewhere even closer, like here in Southern California or California, we are impacting these habitats as we start to sprawl outwards and develop more and more because there's more and more people, right? Habitats are becoming smaller. Habitat degradation is a process of human origin that makes habitats less suitable and less available for animals. Habitat fragmentation is a process by which habitat loss results in the division of large continuous habitats into great or small patches of habitat. So this picture here illustrates it perfectly. So you have this dark green area, which would be probably natural habitat that has been fragmented because of these agricultural fields, or it could be roads or developments or apartment buildings. I mean, it could be anything. So there is a problem now if you have, like, I don't know, a deer that lives here, it will have to sooner or later venture out, either to look for more food, more resources, to mate, right? So that poses a big problem if there is, for instance, a large highway running through this area. So there has been something developed. This is kind of like good news. We usually don't have good news in these classes. These are called wildlife corridors. They are developed specifically for wildlife to take instead of using the roads and becoming roadkill, right? Corridors, wildlife passages, ecoducts, they have many different names. They're important because they help in migration and looking for food. And I have a lot of students that ask like, hey, do they really use them? Yeah, they really use them. They just go by scent, right? So they would take it. And we see them all over the world, and they do help. So that's kind of cool, right? Okay, last part of today's lecture. I am going through it very, very quickly. Our ecosystems and biomes, these are just scales at looking at our biosphere, right? Overall, we would call the living portion of the planet the biosphere, but we can break it down even further. So I love this picture here because it shows how it's like the Russian doll effect, right? You have the individual species. That individual species is part of a population, right? Still the same type of animal. Then you have this population of elk or whatever living in this community, different types of species, right? Then this community exists within this ecosystem, even larger. Now you're looking at not just the living, but you're looking at the non-living portion too. Then this ecosystem belongs within this biome, right? And then the biome is found within the biosphere. So pretty cool way of looking at the living and non-living portion of the environment. Why are ecosystems important? Why is it important to save them, to preserve them, to conserve them, to fight for them? So most of you would say because it's our duty. We're called to be good stewards, right? For future generations, so my children's children can experience them. Yes, those are all correct answers. And that would be like the romantic side of it, right? Like the flowery side. Oh, because it's beautiful, Earth is amazing. And yeah, I mean, that's like why I got into this field, right? But if we want to implement the conservation of these ecosystems into public policy at all, no senator or nobody in office is going to listen to you and say because it's beautiful. You kind of have to attach these benefits or services that these ecosystems would provide, and then you attach a monetary value and say like, hey, if we preserve this park, then we will save this much money in medical bills because less people will have asthma. And that's like, I'm overreaching, but that is like a really good example of why you need to find benefits to these ecosystems, because unfortunately humanity, we don't listen to things if it's not beneficial to us, right? So what do ecosystems provide to us? These are called ecosystem services. It's any positive benefit that wildlife or ecosystems provide to people. So it could be a supporting service, could be provisioning, regulating, cultural. So supporting would be like photosynthesis, creating food, soil formation, right? Provisioning services would be like fish, pollination, cooler temperatures, because I mean, the more parks we have, the cooler the temperatures are. These are called microclimates. Regulating services. So trees store carbon. They clean our air. They purify, water can be more pure. You can control flooding, flood mitigation, clean air, all these things. They are regulating services. And cultural, that's like the flowery side, right? Recreation, aesthetic, stewardship, education. So these are all reasons we should protect our ecosystems because they benefit us, right? I mean, at the end of the day, that doesn't sound nice to me, but if that's how we're going to have these people in office listen to us, then I mean, that's the way it should be, right? In other countries, though, this is a little bit different because other countries rely on ecotourism. People are going to Mexico, for instance, to look at their beaches or the volcanoes, or going to like the Bahamas, right? Or anywhere really in the Caribbean. They rely mostly 90%. Maybe even more on tourism for their economy. So protecting these ecosystems and these wild areas it's much more valuable in other places in the United States, right? I don't think people care about the environment at all in the United States. I mean, you can just, by the way our economy is run, we know that capitalism, greed, and fossil fuels is really what runs the economy. But I digress. So let's look at a larger scale, biomes. This is how we're going to look at the entire planet based on vegetation type. So it's really the type of vegetation there is, and we're looking at similarities and patterns and kind of breaking down the planet into different biomes. So it's usually named and identified on dominant vegetation, but we're also looking at the animals within that biome too, right? So if you were to take my environmental geography class, we would have a whole week of presentations and you would have your own biome and we would get really in depth on it, but I'm just going to go through this pretty swiftly. A biome can have more than one plant type. You know, other types of vegetation do grow, but there's kind of like this dominant type of plant within the biome. So here is your different biomes. Obviously, we're not ignoring climate or precipitation because our dry areas with low precipitation are going to be our deserts, right? Places with higher precipitation, you're going to have more vegetation, maybe more of our forests. Not just rainforests, but there's like tropical rainforest, there's a deciduous forest, there is a mid-latitude forest. So it's kind of just different for latitude, right? Your tropical rainforest is where you're going to have the most precipitation out of all biomes. Consistent rainfall, high temperatures, great biodiversity, layered structure. This is where it's found. Tropical rainforest. Tropical deciduous forest. Now you're moving away from the tropical deciduous forest. By the name, you know you are still within the tropics, right? However, there is less rainfall. Now here you have deciduous trees. Deciduous trees lose their leaves in climatic changes or seasonal changes, right? Unlike the tropical rainforest, you're not going to have trees that lose their leaves in the winter or fall, or the fall or winter. So tropical deciduous forest, you kind of have like this mixture of both, giving you a complex environmental relationships, high temperatures all year. So this is where you would find it, kind of on the outskirts of the tropical rainforest. So you're moving away from the equator. You're still in the tropics. Tropical scrub, you're moving even further away on different sides of the continents, and you're going to have much more dry conditions, but you kind of have this mixture of low growing scraggly trees, tall bushes. You have your dry season and a mild wet season. So it's going to be quite different than your tropical rainforest, but it's still within the tropics. This is very much close to your mid-latitude scrub, which is going to be like your chaparral. So you're looking at the name and it'll tell you where it's located, right? There's a tropical scrub and there's a mid-latitude scrub. Very similar. Tropical savanna, these are going to be grasslands. There's a tropical savanna, there's also a mid-latitude grassland, which are going to be your prairies. So grasslands are obviously lots of grasses, right? So these are tall grasses. The savanna biome has pronounced seasons. You have your very wet season and dry season. You have two types of savannas, African and Latin American savannas. This is where they're located. And then the desert is going to be your very dry biome. Plant cover is sparse. Desert vegetation is variable. Lots of drought-resistant plants. This is one of our largest biomes. Mediterranean woodland and shrub. This is the biome that we live in here in Southern California or Los Angeles. The name of the climate zone is Mediterranean, but the name of the biome is Mediterranean woodland and shrub. They all experience a pronounced dry summer, wet winter. And that's where that's located. Very, very small in terms of biome. California chaparral, I gave you guys a huge lecture on this in chapter 8. So you guys, this is probably the same thing. There you go. Mid-latitude grassland, North America and Eurasia. In North America, it's called prairie. So this is where it's found. Parts of Mongolia, North America. And your boreal, this is the most extensive biome, also known as a taiga. This is on the fringe of, sorry, I meant something else. North America and Eurasia, so parts of Canada and Russia. Harsh climate, very cold, but not cold enough to where there's no plants. So floristic homogeneity, which means the same types of trees, really. It's just going to be coniferous trees, pine trees. Slow plant growth. This is where it's located, all in the northern hemisphere. Why? Because at these latitudes, there's no land in the southern hemisphere. And then the tundra is a cold desert or grassland. Moisture is scarce. Summers are short. Trees cannot really survive. You really just have lichens and mosses. That's about it in the tundra. And this is where it's located, just at the very, very top of the boreal forest. So that's about it.